Okay, let's start. Hi folks. Hi everyone. I'm Vitaly Bragilevsky. I'm a developer advocate at JetBrains, and I'm happy to be here today. So please, folks, tell me who uses IntelliJ IDEA. Yeah, and thank you so much for that. So it's always rewarding to see folks actually using our product. So it's great to know that there are so many folks here. Yeah, so today I'm going to talk about IntelliJ IDEA debugger, one of the important tools which we developed at JetBrains. Of course it's integrated with IntelliJ IDEA, and you know, like I started learning code in 90s, so 30 years ago. And for me, there was always a baseline of what does it mean to debug code. Like, for example, in my early years, I had something like this. Does anyone know what is it? Oh, great. Yeah. So I'm not that old, okay? So yeah, it's Turbo Pascal, which is an IDE from Borland. And actually, we can see here this very baseline. So we can put breakpoints in our code. We can analyze call stack. We can add watches, some evaluate expressions. We can see register values. We can evaluate stuff. We can modify something. So this is something that we have in every single debugger available out there. But the thing is that debuggers are no longer there, actually. So we are 30 years from that. So when we are speaking about actual debugging, we mean something different. So debugging is not about fixing bugs, or like if you have bugs in your code, then you find them and you fix them, and that means debugging. No, debugging is not like that. There is some folks say that, well, if you have bugs in your code, then you are the bad one. Like it means you don't follow the right approach to develop software. Like, for example, you don't use test-driven development, and that's why you have bugs, and that's why you need to debug your code, and that's why, so good guys don't use debuggers. No. Debugging is more about understanding what's going on with your program at runtime. So you see, you can read your code and you can understand something. Then you can apply static analysis tools, and we have such tools in IntelliJ IDEA, of course, but that gives you static picture. And if you run your program, and if you want to understand what's going on at runtime, then you use debugger. Even if it's like perfect program and no bugs in it, it's still useful to understand what's going on. So here I'm going to show you several debugger features which helps you to do exactly that. Of course, it's also possible to learn something about memory. I'm not going into details about memory debugging in this talk. So I will talk about code behavior. So that's an idea of this talk, and everything I'm going to show follows exactly this approach. So we want to realize what's going on with our program at runtime. That's an idea. Sorry. And I will start with this example. So do you know what is a hot swap? Anyone? Hot swap? So it's like if you run some Java program and you want to replace some code while you are running it. So that's a hot swap. So you can change some code and reload several Java classes and get some different behavior. So okay, let's look at this example. So as I said, chances are there are no bugs in this program. Maybe everything works just as it should. But we want to understand what is actually going on. Like, for example, let me start debugging this program. So I'm running a debugger, and at this point, like, program doesn't do anything. Why? Maybe I should input something. Okay. something like that. No, like it waits for something else. Okay, maybe something like that. No, it still works. So this is, so we are, maybe someone else wrote this code. Maybe I wrote this code, but a year ago. And to be honest, we all developers know that me 1 year ago is not me. It's someone else for sure. So we need to understand what's going on. And the first idea here is to just stop our program at this point and explore where we are. So if we stop this program, we'll see that it's some read bytes function. And it's not our function, it's somewhere from JVM. And if we look here, so there is this stack. It's read bytes, read, something else, something else, something else. And now we can see next line. So this comes from scanner, and that means someone's still reading something. So we can go to this part. So here you can clearly see this is, yeah, is it visible? Yes. So there is a JVM part and there is our own part. So okay, let's go to our own part. So yeah, here we are. It's a scanner. And now we know this function read. It's our function and it has one usage. So it's somewhere here. Now, when we are like discussing what's going on at runtime, we don't want to stop our program and run it once again. While we are here, debugger allows us to go forward, but it also allows us to go backwards. And this is not possible for every programming language, for every debugger, but we are lucky enough to have this feature in Java. So Java debugging is extremely powerful in this regard. So we can go both ways. So one of the features I can show you here, like, so we can go further and we can go back. But right now we are in JVM. Well, we cannot do much with JVM. So let's do something like this. So I'll just go to this function where we call it. I'll put a breakpoint right after that. Now I know I just resume my program. I will input something else just to stop one call. And now I am here. I am outside of JVM. Now I am debugging my program. And here's what can I do. For example, I don't want to input something here. So what I want to do is to return some string literal. Hello, for example. Okay. And right now, let me recompile my program. So in Java, it is possible to reload only those classes that are changed here. So let's reload them. Okay. And now we just once again, so I'll remove that breakpoint here, and I'll run the program. And now what can you see here? There is no waiting anymore, because now we have a brand new implementation of that read function. So we've changed the code at runtime, and there was only one run. I never stopped this program. So this is possible. So we can do that with a hot swap feature and combined with IntelliJ IDEA debugger. Okay. There are other things here. So maybe you don't want to change your code. And in fact, it's not always possible, especially if you are working with external libraries. It's impossible to change code in external libraries. But there are other things that are doable. So once again, I am running this very program, and I have this breakpoint. And before actually entering something, so I stop here. So it expects some input from me. So what can I do? I can, for example, I can do force return. So I can specify a return value for this specific method right here without expecting some input. It's called, like, once again, how I do that. See, so I have this menu here, force return, and then I can build any expression. So this method expects strings, so I have to build some string, okay, and I can return it. But in general, you can build any Java project, any Java class if you want, right here, this place. So no problem at all. And now we are out of that function, and this was the result. So we can actually see it. So just one step over, and this string is now AAA, the one that I returned without actually expecting any input. So force return, we have a method in the debugger, we are in that method, and we can force return value, which can be anything. And if you look closely, apart from force return, we can also throw exception. So if you want to throw expression, new interrupt exception or invalid arguments exception, anything you want, you can build it right there while you are running this code inside the debugger. So look, the idea is to modify program behavior at runtime. So it's not only about understanding it. It's also about modifying. Why do we need that? Well, for example, we have a very long program. Compilation takes a lot of time, and you just want to check your idea. So maybe it will work better if this value has the if this variable has this value. And in that case, you just use all those features: force return, throw exception at this place, and something like that. Okay, so that was example number 1, where we can change code, we can force return value, we can throw exception. Okay, let's close this for now, and I will go to my second example. Lambdas. Who likes Stream API and Lambdas in Java? Yeah. Oh, nice. Like, I'm coming from Haskell ecosystem, you know, that programming language, pure functional one. It's impossible to write code without Lambdas there. So I'm glad that you like this stuff in Java as well. With Lambdas and with Stream API, we always have this problem. Look at this line 94 here. It's quite long, right? Because we have like filters, we have maps, we have everything else here. Is it possible to debug code with these long lines? You can tell me. Of course, you can split these using like several lines. Just press enter several times, and then there will be several lines there. Well, you can do that. But the thing is, if you are forced to do something with your code to be able to debug it, then that means that IDE is failing you. So IDE should make it possible to debug whatever you want to write, and not to require you to do something with your code by yourself. No, IDE is here for helping you. So what we can do with these long lines? If I set here breakpoint at this line, it's a breakpoint for the whole line. But now, look closely. We have these so-called Lambda breakpoints, these dots here. So Lambda number 1, and then, okay, and then another Lambda here for the line. So we can put a breakpoint in every Lambda that we have in this line. So, for example, here, all right? And then I don't need this one. So I can switch it off, and now I have only one Lambda here. So let me start debugging this code. And then we'll stop right here. Okay, so at this Lambda. Of course, while we are at Lambda function, normally they are short, and there is not much to do here. But still, we can explore variables that we have at this point. And then we can do something else. So we can like step over, for example, here. And and this goes over the over other values in this list that I have. Okay. So another thing, if I have a breakpoint on the whole line, like in the very beginning, and I also debug this code, then we have so-called smart step over, or maybe not step over, sorry. I will do this step into. Look, this stream, filter, and these lambdas, they have different color. And that means that you can choose where to step into. So you don't want to put breakpoint on every lambda, for example. And at this point, you are interested in this or in that. So you just go, okay, I want to look at this starts with behavior. And here we are. We just move to this particular lambda. So it's very convenient. So you don't need to break your code into several lines. You just have this code in one line, and you can easily go from one point to another. Okay? And there is one more thing here. Like, I don't know, Stream API is with us for many years. And many years ago, we've implemented one very nice feature, which it looks like which is not very well known. Okay, so I will show it, this feature to you. So we're going here to this line. So we go into this chain somewhere, like for example here. So we have this stream, and then over it. And we have this command, trace current stream chain, which is, it shows you the whole process of transforming your stream. Of course, if you have many data, like many elements in your list, then it's not that visible. So it normally works better with list values, with short test values. For example, here we have 5 elements in this list, and we have this original stream here, and we are inside debugger for that stream. And then we can look at what is the result of filtering. We have 2 filters here. So we go from those 5 elements to 2 elements. I am taking longer names. Another filter starts with, and we have 1 left. And then we are mapping it to something. And then we are transforming everything to list. So we can just trace everything that is going on inside that stream processing. And we can also show everything like this in this so-called flat mode. But of course, if there are several stages of processing, it's difficult to see what's going on. So sometimes it's better to go step by step. So if you want to understand the behavior of your stream processing, just go here. So it's a stream trace command inside your debugger, and then you get the full picture of what's going on in this program. So who never heard about stream tracing in IntelliJ IDEA? Okay, so good to know. So that means that you've learned something new here. So this will be a nice addition to your skill set, debugging with IntelliJ IDEA. That's very nice to know. All right. Next example. So you see several very short examples, but everything is right there inside IntelliJ IDEA debugger. So many features. And the problem with those features is that sometimes they are undiscoverable or difficult to discover. You just don't know what to look for. And let me say one maybe a little bit stupid thing, but you know, every feature I'm talking about is described in every detail in IntelliJ IDEA documentation. So while preparing this talk, I was looking through, well, other talks from my colleagues, and also I looked at documentation, and it's right there. So if you read documentation, you will see this like much more than I am able to tell you, to show you in this short talk, okay? So please read documentation. There are a lot of nice features in IntelliJ IDEA debugger. So my next example is method breakpoints. With method breakpoints, there is a caveat. So we have JDB, Java debugger, and it's well known that in Java debugger, JDB, method breakpoints are implemented so that they make everything much slower. There is a reason for that. I am not blaming anyone here, because if you want to put your breakpoint on the method, and you don't know where are the implementations, and they can be loaded any moment, so it's very difficult to actually trace everything with methods. But here in IntelliJ IDEA debugger, we use so-called emulated method breakpoints. They work as if they are method breakpoints, but they are implemented differently. So what I mean here, so we have an interface, this base interface. And then we get implementation of that interface from somewhere. And you see here that this function, method boo, has some usage, and this one, foo, is unused, according to the static analysis available in IntelliJ IDEA. So IDEA tells you foo is unused, which means IDEA failed to find any usage for that method. Okay? So method breakpoint, you see this diamond here. This is, so before we were looking at line breakpoints, and here we have method breakpoint. So if we put it here and run debugger here, then we'll stop at some method which actually implements this interface method. The implementation is, well, technically simple. IDEA just looks for every implementation in the code base and add breakpoint, line breakpoint at the first line of that implementation. So nothing magic here. But, so with boo, it was like originally, it was all right to know that because there is one usage. What about foo? Let's try to look at it as well. So we have this breakpoint, method breakpoint at foo, and we run the debugger. And it turns out there is something as well. So we have this implementation. So any ideas how can that happen? So we have like no usages in IntelliJ IDEA, but still it's doing something. It is called. So how is that possible? Like small Java quiz here. Sorry? No, I don't think so. Anything else? Reflection. So we can actually call everything. So we can, so there is no usage, means that we never say like method foo, but we can, using reflection, we can combine with this name somewhere in this code, and of course we do that reflection right here. So this is like really what we do. I don't know, it should be, yeah, here we are. So we are building this name somehow, and then we call it. So it's still possible. But what I'm showing you here is that method breakpoint helps you to find this thing as well. Because, like, you know, well, you put breakpoint, and then you stop at it, and you can understand how did you get there. So you just go over your code and see. And it's actually visible right here in the call stack. So we have this do something, get object, so we can just look at the stack that we've got and realize what's going on. So method breakpoints, different sort, diamonds right there. Okay, next example. You know, like for many years, I was teaching programming languages in universities. And one of my biggest problems for those years was so-called print line debugging. So when folks, instead of using the right tool, they are trying to put like this system out println everywhere in their code, and then try to figure out what's going on. And then they read those lines in the output, and when they're unhappy with the result, they add more print lines and recompile everything and run their program again and again and again and again, and spend a lot of time to actually try to understand what's going on. So the good news is that almost never you don't need to do print line debugging, because in many cases you can figure out what's going on without them. And IDEA debugger has features that allows you to do printing if you want that, without actually adding print line instructions into your code. So this is very easy to do. So here I have this example. We have some static variable instance with some cache, and our code suggests that we don't want to create new cache every single time. So if it's empty, if it's null, then we create it. If it's not, then we just use whatever we have. And here, look what I'm doing. Well, it's not magic. It's a very simple thing, but you know how to do that. So I select this variable here, and now I press Shift and click. I am creating so-called evaluate and log non-suspending breakpoint. It is not suspended, and that means that it won't suspend your program when it's hit. It will just print something, and in this case, instance, it will print the value of that variable, okay? So let's run this code on the debugger, and let's see at console. So it's just printing, well, reference to this variable. It is first in the first run, it's null at the first run, and then it's just this variable, and you see that it's the same. So you just you see that, well, it works. Okay, but so let's look closely to the properties of that. So we can also log some additional information. For example, we can say this breakpoint hit, so and we'll see that it's hit several times. So let's try again. So we have this breakpoint, and we run it again. Now we have this information, so where we hit it. So breakpoint reached at this point in our program, all right? Okay. And what is even more interesting, we can not only evaluate and log, we can actually write anything here. So for example, we can print this instance, and then we can say something like this. Instance. And you see that you get almost full support here. So just really something that you can do. So full ID support, I mean, there is code completion and all that stuff. Okay. Right. Run it. And now you see that it is not only printed, evaluated, it is also changed. And now you can see that these references are different. So it means that it is created every single time, because it's always null. It's printed, it's null, it's printed, created, and it's printed again, it's all null again. So without actually doing something with your code, you can change its behavior. So if you want to test something regarding that instance, well, you can do it this way, using non-suspending breakpoints. So you don't have to stop your program. You don't have to analyze manually at runtime. You can analyze what you've got as a result without any print lines here. This is important, okay? Who did ever use non-suspending breakpoints in IntelliJ IDEA? ever use. So, well, folks, please use them. Use them instead of print line debuggers, print line debug statements. Because, well, we all know that problem with debug statements. If it's there, it will stay there forever. You will ship your product with those debug prints. You will never be able to remove all of them. Am I wrong here? So you're able to remove all of them. Well, you're lucky, I think. Well, because, so it takes time to recompile, it takes time to just check everything, and if you are like for 4-5 hours debugging, you just forget it, and then you do code review, and then you don't just miss it, and maybe there are many cases. So of course, if you have proper like review management, then of course you will get rid of them. But if not, well, they will stay there forever. All right, so non-suspending breakpoints, and then please don't forget this. To be honest, I learned this 1 week ago. So this one, once again, this shift click, and it's like here, yeah, and oh no, and it's there for like 5 years, maybe 6 years. So we just select some variable, or it can be expression, any expression, it will also work as well. And then shift click on the getter, and then you will find your non-suspending breakpoint. Okay, very nice feature. Okay. Okay, more time, more examples. Complex workflow. So here, I have very complex workflow for my program. So there is some process here with ID, and this process function calls step 1, then we do something. That step 1 method calls step 2. Step 2 calls step 3 and step 4. That means that we are doing some sort of branching here. And then step 3 called output. Step 4 calls some action. Action calls output. So, well, really very complex workflow. I hope there is nothing like that in your code bases. Or maybe I wish you not to have anything like that, but still things happen. So, and I want to debug something in this output. In IntelliJ IDEA, we have this very nice feature, which is static analysis, actually, which is not a debugger feature, which is called analyze, and where is it? Where is it? I don't see it. Okay, maybe. It should be here, maybe. Okay, let me die. Analyze. Data. Yeah, analyze data flow to here. So did you see what I did? I use shift, another shortcut shift, and then I remember that it should be there. So I just write several words from the name of the action, and here we are. So it's often like, well, I don't remember where it is, what's the shortcut, just don't remember. So I can do it like this. So to here. And I ask to search for a whole project. So it's the story of that parameter ID. So it is used in output. And then we have these 2 lines. So one comes from step 3, another one comes from action. And in step 3, we can see like we're going backwards. It's step 3, step 2, step 1, then process, all that. So this is static analysis feature. We're not running our program yet. But, well, we have it here. Now, the thing that I wanted to show you here is this one. Imagine that you're not interested in, like, for example, output which comes from step 3. Instead, you are interested in output which comes from step 4. But if you have a breakpoint, it will hit in both cases. and you are not interested in both cases. So how we do that? Okay, let's debug this program. So we reach this breakpoint, and in this particular case, if we analyze this stack trace, we see that it comes from step 3. And we are not interested in this part of the program. So what we usually do in this case, we hit the breakpoint, we see that it's the wrong point, so we continue running our program until we hit the right breakpoint. Okay? So that's what we do. And if this breakpoint is reached many times in our program, and some of them are good for us, and some of them we are just not interested in them, then it takes a lot of time to debug this program. So we have an ability to say that, well, please, debugger, don't show me this stuff. I am not interested in it. How I am doing this? Well, we have this altenta or option return. Do not stop in the class, for example, or stop only if called from step 3. Do not stop if called from step 3. So this is extremely powerful. You just want to explain to debugger when you are going to stop at this breakpoint and when you don't want to do that. So if I do this, do not stop if called from step 3. Now let me stop, and then yeah, I debug again. Now I'm here again, and now I'm coming from step 4. So I just skipped that breakpoint when I got there from step 3. So this is really powerful technique. So how does it work actually? Let's see. It's all there in the description of this breakpoint. And you see I have used caller filter here. The problem with these caller filters is that it is very difficult to write something like that on your own. Look, it's Java names. So there is some name mangling here. You have these dollars, you have arguments of the method mentioned here using this syntax. It comes from Java. So you never want to write these names on your own. Never. It's always a bad idea because it's very difficult to make it right. But as I showed you, it's possible to add that at runtime. Because at runtime, debugger knows everything about those methods. It just helps you to describe what you are interested in. So once again, let me show it how I did that. So I stop at this breakpoint, and then this intention, or you can just altenta. You know, there is this so-called altenta-driven development. If you write some code, then you press altenta, and then there are suggestions, and you try to apply them. So here in the debugger, we use it as well. So here we have several ways to say, stop here, don't stop here, and then you will fill all those filters, and then you can use them. All right? Okay. I have more examples to show you. So this one was 6. Okay. 7. Concurrency test. My favorite one. Nice. Well, that's concurrency. Yeah, concurrency bugs are like that, you know, it's always like that, yeah. Okay, do we have a chance to see my screen? Yeah. Yeah, you know those demagogues who are always powerful when someone is doing demos. Yeah, nice. So concurrency test. Yeah. Okay. So an example is very simple. I have a list here. So it's synchronized, if you know what it means in Java. Well, and in Java, if you know what it means, you know that it does not mean what it says. Okay? So I am calling a method add if absent. And this method checks if this list contains some x, does not contain some x, then add this element. So I am adding the same element 17 here and here. And the thing is that it should not be added, right? Because it's the same element. So test actually checks that this list has size 1 after this operation. So I'm adding in this thread and then in the main thread. That's an idea. So it's something about concurrency. If you see, it's green, so it passes. So if I run this test, then of course it passes. In IntelliJ IDEA, it's possible to, well, we know that with concurrency, it passes once, it passes twice, it passes 100 times, it passes 1,000 times, but then there is a problem. So what we can do, if we modify run configuration, we can say something like this: modify options and say repeat this test until failure. Very powerful feature. Now let's try. Oh, 1,000 times, so 1,600, it passes, but then it fails. And we are lucky, I should say, because like when I tried this at home, it was, I think, 600,000 times until failure. Okay, so why is that? Okay, so I'll show you the actual reason. But the idea is to show one nice debugger feature. So I will say suspend thread. Like by default, IDEA suspends every part of the program. But here we are trying to find something about concurrency. And that means that we need to stop on every thread to make some wrong order of operation that leads to this concurrency error. That's an idea. So I run this program, or I debug this program. Look, I stop at this line in one thread, in the main thread, and then it also stopped in the thread 1. So in both threads, I am at this very breakpoint. And now list doesn't contain this element. Okay, so what I am doing, I am doing step into in one thread, and then I go to another thread. I am doing step into as well. And now we will just add this element twice. So we've just repeated the same test error. You see, so it's just, it will fail. No, like this one. Yeah, in another thread, we should also resume it. Yep. And test failed. So with a single run, because we've managed to run our threads in a way that are actually lead to this concurrency error. So once again, how I did that. So suspending thread and not all. So breakpoint and then suspend thread, and then we just try step by step manage our program to this concurrency back. And once we are there, we can easily figure out what's going on in the wrong way, so we can fix it. So IntelliJ Debugger is extremely powerful. There are many features. I just showed like one small part of those features. So please read documentation. There are other talks available online about IntelliJ IDEA Debugger. So please use debugger, don't use print line debugging, and thank you very much.